Hi, everybody. In science, it turns out that every time that we do an experiment, we make a little bit of an error. And sometimes the error is due to our own mistakes, and sometimes it's due to the instruments that we use, or maybe there's other reasons as well. But every time you do an experiment, you make a little bit of a mistake, and today we want to learn how to deal with this. Well, it all starts off with understanding two terms, and those terms are accuracy and precision. And accuracy is defined as the closeness of measurements to a correct or an accepted value. How close are you to what you're supposed to get? Whereas precision is the closeness of a set of measurements. So to illustrate this, I'd like to tell you about a long time ago when I grew up way out in the country in Wisconsin. And one summer, my friend Bo and I, we went out and we practiced with our archery equipment until we were as good as we could get. Anyway, that first year that we decided to go bow hunting, we went turkey hunting, and a gobbler came out of the woods, and he was gobbling away. And my buddy Bo, he pulled back his bow, and he looked at that turkey, and he let his arrow fly. And one after another, he just put a big group right there on a tree, right behind that old turkey. It was just like this. And I congratulated Bo because he was there was something darn good about what he did there. Every one of his arrows landed in the exact same spot. Well, he didn't get the turkey, but it was still good shooting. Turned out that Bo had excellent precision that year. Well, all right, so Bo, he was the dedicated guy. So the next year that we went out, it looked like the same turkey actually. It came out, and boy, that turkey he was in danger because Bo had been working on his accuracy that summer. All right, so he pulled back his bow and he let fly with one arrow after another. And the first arrow landed here, and the second arrow was way down here, and then the third arrow and the fourth arrow. He had a big quiver full of arrows. And these are actually where these arrows all hit, right like that. So if you look at this, bam! Look at the average of where these things are hitting, right there. Oh my goodness, that is a dead turkey, isn't it? Because he had excellent accuracy, but his precision wasn't so good. All right, so Bo, he wasn't too smart, but he knew that he had to work on both accuracy and precision for the next year. So the next year we went out in the woods and we were sneaking around, but we didn't see any turkeys. And it's lucky for the turkey because this is an actual picture of one of Bo's targets after he got done shooting. Oh well. Okay, so whew, boy, that brings back memories. But I guess what I want to talk about today is accuracy and precision. So up here, these arrows represent a close set of measurements. So this year, that first year, Bo was very precise. Here, if you look at the average of all of these shots, the average is right probably about where you want to hit this. And so that shows good accuracy. And down here on the bottom, on the target, that shows both good accuracy and precision. Doing. Pretty cool, huh? All right, so let's talk about error in measurement. So error exists in every measurement. It could be that we don't have the skill to really measure things as accurately as we should, although we'll work on that in class. It could be that the temperature or the pressure of on the atmosphere expands or contracts the chemicals or solutions a little bit and sort of messes things up. It's often that the measuring instruments are only capable of going to a tenth of a milliliter or a hundredth of a centimeter or something like that. So let's take a look at some results. So this is just like when Bo and I went hunting, but these are more scientific types of results. So anyway, here we go. So we decided to boil some water one day, and we had Tristan and Homer and Maddie go out. And they each went to their own little places, and I said, all right, you guys boil some water. All right. So Tristan did that, and he measured the first one. The water was boiling away, and it said his thermometer said 101.5 degrees. And so he poured that water out, and he filled it full of water again, and he boiled some more water. And then this time he said, all right, 95.6. All right. And then the next time he did this, he got 99.4. Now, if you look at the average of this, all right, let's take a look here. Move this over. 101.5 plus 95.6 plus 99.4 equals 296.5. We have to divide by 3 because he did it 3 times. So his average was 98.83. 98.83. Oops, just a second. I wish this thing would just keep the pen going. What was that? 98.83? 98.8. Oops. 3. Now, if you look at what Homer did, he got 102.6, 102.5, 102.4. Good job, Homer. If you look at the average of this and you add them up and divide by 3, I'm pretty sure that will end up being 102.5. Now, if you look at what Maddie did, she had 100.2. She had 100.0 and 99.8. And if you add those up, the average is 100.0. Nice. So let's analyze these. Well, you know what I'm going to ask you. Which one had better precision? Which one had better accuracy? Which one maybe had both? Which one had neither? Well, let's look at Tristan's number. 98.83, a little bit on the low side. And boy, they varied a lot. 95.6 all the way up to 91.5. Tristan did not do a particularly good job with his, his precision, because they're so spread out. His precision was not so good. Now, Homer, oh my goodness, look at that. Very precise. Good job, Homer. But you kind of missed. The answer is supposed to be 100, and you got 102.5. All of your numbers, however, were close together, so you had good precision. But your accuracy was not good at all. Now, Maddie, on the other hand, isn't she amazing? 100.2, 100.0, 99.8. Pretty darn good precision. All the numbers are close to one another. Pretty good. Maybe not quite as good as Homer did for precision, but her accuracy was spot on. So you did a great job there. Okay, accuracy and precision. All right, now every time we do an experiment for the rest of the year, or practically every time, I'm going to ask you to calculate the percentage error, or the percent error. And the formula looks rather daunting. It says percentage error equals value experimental minus value accepted divided by value accepted times 100. Well, it's percent error, so that's why you multiply times 100. And then these numbers, what I usually say is, this is what you got, and this is what you're supposed to get. All right, so you find the absolute value, actually, of these two. All right, so that means it's always a positive. And then we'll have to just think it through. All right, and then so you get the absolute value of those, the difference between what you were supposed to get and what you got, and then you divide by what you're supposed to get. How much you missed by divided by what you're supposed to get times 100. I guess that's how I usually say it. How much you missed by divided by what you're supposed to get. So the accepted value is the one you look up in a book, or it's given to you. Like water is supposed to boil at 100 degrees. So that's the accepted value. So here's a problem. You measure the mass and volume of a substance, calculate its density. You find it to be 1.4 grams per milliliter. But then you find out that, wait a minute, it was supposed to be 1.30 grams per milliliter. What's your percentage error? So how you do this is, because this is an absolute value, you can subtract either way, but to make my life simpler, I will go like this. I'll say experimental 1.40 minus accepted, I was supposed to get 1.30 divided by what I'm supposed to get, 1.30, and then last but not least, I'll multiply times 100. All right, so that's a times right there. And what does that give me for an answer? Well, all right, so it is 1.4 minus 1.3 equals divided by 1.3 equals times 100. And the answer is, ready, 7.69%. 7.7% error. That's how much I missed by it. And so at this point, okay, over here, 7.7% error. And then what I'd want to do is I would just use words to say, well, let's see, my value was a little bit too high. So 7.7% too high. And I would just write that down. T-O-O-H-I-G-H. That would be my answer for my percentage error. Okay, so today we looked at a couple of things. We looked at accuracy and precision, and then error and measurement, and how to calculate percentage error. Thanks, everybody.